What does the source say on that front?
This is critical. The metallic fuel apparently runs much, much cooler, over 1,000 degrees Celsius lower operating temperatures than standard ceramic fuel.
1,000 degrees cooler, that sounds like a massive safety margin
It
increase.
really is.
Yeah.
And related to that, the source emphasizes that it eliminates the risk of hydrogen generation during an accident scenario.
Which was a huge factor in, like Fukushima, right? The hydrogen explosion.
Exactly. So removing that specific risk pathway, that's presented as a major potential safety improvement.
Okay, what of the back end, the waste?
The source claims it produces less plutonium in the spent fuel, which, links to reduced proliferation risk, less material of concern being created.
So putting it all together from the utility perspective described in the source, potentially more power, longer operation between refueling, significantly higher safety margins, less problematic waste, all without needing a brand new plant.
That's the picture the source paints, making the existing global fleet work better, safer, and more profitably.
Okay, but an idea like this needs serious validation. Nuclear isn't exactly a move fast and break things industry. The source talks about government support.
Yeah, and that's crucial for credibility, not to mention resources. The Department of Energy is highlighted as a key partner. They're supplying the enriched uranium needed for testing.
Which isn't trivial to get.
Not at all. And providing access to the technical facilities, specifically mentioning Idaho National Laboratory.
And there's a big test coming up soon, right?
Yes. The source points to reactor irradiation testing scheduled for 2025. That's the key milestone. Putting fuel samples inside the Advanced Test Reactor, the ATR, at Idaho Lab.
The ATR, okay. And they're using a specific method, FAST, F-A-S-T.
Right, fission accelerated steady-state test. The significance, according to the source, is speed.
Speed in nuclear.
Relatively speaking. The source explains FAST uses smaller samples and higher enrichment to basically simulate years of real-world reactor conditions, wear and tear, but in just months.
So it compresses the timeline.
Exactly. The insight is that this could potentially shave years off the traditionally very long pathway for qualifying new nuclear fuel. That's a potential game changer for development speed.
Cutting years off, that would be significant. Is there other validation happening? Third parties looking at this?
Yes, the source mentions a couple of points adding to the technical picture. Researchers at MIT presented findings earlier this year, 2024, at a major fuel conference.
And what did they find?
Their analysis, as reported, confirmed the fuel offers superior thermal margins and safety buffers compared to standard fuel. So, an independent academic look backs up those safety claims.
Okay, that adds weight. Any look at different reactor types, because not all reactors are the same U.S. design.
Good point. The source also mentions work by an institute in Romania, right in ICN. They looked at using Lightbridge fuel in CANDU reactors.
CANDU, those are the heavy water reactors, common in Canada, elsewhere.
Right. And their study, according to the source, found the fuel could potentially double the energy extracted the burnup in CANDUs, even using lower enriched uranium than initially thought.
Double the burnup. That's huge for fuel efficiency. Okay, so you've got DOE backing, upcoming ATR tests using an accelerated method, MIT confirming safety margins, and studies suggesting it works well in other major reactor types like CANDU.